Getting ready for 6th grade, Lesson 1 Essential Question. How can you compare decimals, fractions, and mixed numbers on a number line? For this lesson, we need to remember what benchmark means. And they're just easy to work with numbers, the numbers that first come to your head. With fractions, the first fractions that come to my head are like the whole numbers, like so there's 0. But then the next one to me would be like 1/4, and then 1/2, which is the same as 2/4, 3/4, and then the next whole number, so 1. Those to me are the benchmark fractions. Then we're also going to be working with decimals. When using decimals, I generally think in terms of money. That's not to say that you have to always do that, but I think of quarters. And so what are the decimals that represent a quarter of it? Because that actually is going to be equivalent to our fractions. So again, I start with like 0, the first whole number, and then the next one would be 25/100ths, because that's the same as 1/4, and then 5/10ths, which is 50 cents or 1/2. That's a benchmark. It's an easy number that I can work with. And then 75/100ths, and then the next whole number. And last, we also need to think about mixed numbers, which is just a whole number and a fraction together. And also mixed numbers can also be a whole number and a decimal, because decimals and fractions are equivalent. They're just written different ways. So a mixed number, you have to have gone past a whole number, so I'll just say there's 1, and then if we're doing a fraction, it's 1 1/4. If it's a decimal, it's 1 25/100ths. And then like 1 1/2 would be the same as 1 5/10ths. And 1 3/4 would be the same as 1 75/100ths. So these are the benchmark fractions, decimals, and mixed numbers that I keep in my head to give me some landmarks or benchmarks on a number line. Unlock the problem. The tech club compared the weights of 3 cell phones. Esteban's phone weighed 4 7/10 ounces. Jill's phone weighed 4 3/5 ounces. Mona's phone weighed 4 3/5 ounces. Who has the phone with the lightest weight? Squiggle underline what you're being asked to find, circle the important numbers, and then straight underline any words that would help you know what operation to do. You should have squiggle underlined who has the phone with the lightest weight, circled the 3 different weights they gave you, and then I actually just straight underlined the word compared to show that we needed to place them in some sort of order. And right here it says you can use a number line to compare fractions and decimals. Now if we're using a number line, how can we identify the number with the least value? On a number line, is it going where on the number line would be the lightest or the least value of weight? Write that right here in the box. I wrote the weight that is the farthest left will be the least in value, therefore the lightest. So now we need to compare them on the number line. We need to locate some benchmarks, and remember, so we have decimals. There's the whole number of 4, and then 4 25/100ths, 4 5/10ths or 50/100ths, 4 75/100ths, and then 5. And then they also did 5 25/100ths. And then the mixed numbers, because we're not between 0 and 1. So we had 4 1/4, 4 1/2, 3/4, and then 5, and then 5 1/4. The next step is to actually mark the weight of each cell phone on the number line. And they did this for you, but how could you have done this on your own? In this case, I would start with the decimals, and the scale that they used would be a great scale for you to use in the future on other problems, because right here we have 4 25/100ths. How many ticks are there between the two? There's 1, 2, 3, 4 ticks, so that means there's 5 spaces. So 1, 2, 3, 4, 5 spaces. So how much is each space worth? Well, it's worth 5 hundredths, because if you counted it by fives, you would get 5 hundredths, 10 hundredths, 15 hundredths, 20 hundredths, 25 hundredths. So on the decimals, each tick mark, it's kind of counting by fives, or 5 hundredths to be specific. So if you locate the 4 and 7 tenths, we can start right here with 4 and 5 tenths and go 55, 60, 65, 70. And you can see that right there is the 4 and 7 tenths. And then I'll just put a little mark to say I've already done that. And then I'm going to move to the other decimal, 4 and 35 hundredths. And I could again start at 4 and 25 hundredths and go 25, 30, 35. Oh, that's as far as that one needs to go. And so far I have 2 of them labeled. Now the fraction would be a little bit more difficult. In this case, I would actually turn my fraction of 3/5 into a decimal so that I'm only working with decimals and not decimals and fractions. Now the way that you do this, we've already done this before, but remember a fraction is another way to write division. So right now I'm going to ignore that 4, and I'm going to do right up here in the corner, I'm going to go 3 divided by 5. Now I know there's no 5s in 3, so I add my decimal and add a 0 and bring my decimal up. How many 5s are in 30? Well, there's 6, and that would give me no remainders. So 3/5 is the same as the decimal 6 tenths. So I could write it as 4 and 6 tenths instead of 3/5. And where would that be? Well, there's 5 tenths, and then remember, it kind of counts by 5 hundredths. So there's 5, 55, 6 tenths. And so that goes right here. And so now, which phone is the lightest? Well, we can tell that 4 and 3/5 is the farthest to the left. 4 and 3/4, because that's this one, the 6 tenths, is in the middle, and then the 4 and 7 tenths is to the farthest right. So who had the 4 and 35 hundredths ounces? That was Mona's. So Mona's phone is the lightest. Now we're going to look at the try this. It says compare 1/5, 5/8, and 2/10. Which number has the greatest value? So this time we're looking for the greatest, which is going to be the farthest right. Now, with the 1/5, I would still divide that up and find what that would be with a decimal. 5/8, I can work with the 8 as the denominator because I could find the equivalent for my 1/4 and my 1/2. Those work nicely with 8, so I can leave that fraction for now. And then this one's already in a decimal. So go ahead and place your 2/10, or they did, but locate the 2/10, and you can see that it's right here. And if you counted, you'd have 5/10, or 5 hundredths, 1/10, 15 hundredths, and then this would be the 20 hundredths or 2/10. So we have that one right here. So that one's been marked off. Let's do the 1/5. Quickly do a little quick division. So I can see right there that that's going to be a decimal 2, that's 2/10. So I can see that 1/5 right here is the same. And so for my 5/8, what I'm going to do is I'm going to look at my 1/2 and say if I was going to rewrite that with a denominator of 8, that would be 4/8. And then the 3/4, which is my other benchmark, if I was going to rewrite that with a denominator of 8, that would be 6/8. So 5/8 would be right between the two. And even though it's not on a tick mark, I can still kind of eyeball the middle and find my 5/8 right there. And so, which one is the greatest number? Which one has the greatest value? Well, we can see that the number on the farthest right, the greatest value, is 5/8. And so your answer is the greatest number is 5/8. And we figured that out because it was the farthest right. Looking quickly at the math talk right here, it says, explain how you can tell that 1/5 and 2/10 are equal. Well, there's two ways. One, you can see that they are on the same spot on the number line, and from this division right here. For your share and show, you need to press pause, and then you work through 1 and 2 using this number line, and then number 3. After the share and show, I will be going over the answers, at least, of the on your own and problem solving. So press pause and work on the share and show. For number 1, we're identifying point A as a decimal. We can see that point A is right here, and that's 3/4, but we're looking at decimals, so that's 75 hundredths. And the pattern again, with our tick marks, is each one is worth 5 hundredths. So I could start at 5/10 and count by 5s up, or I can go 75 hundredths minus and count backwards by 5 hundredths. And so I'm going to count backwards, 75, counting backwards by 5. My decimal is going to be 70 hundredths or 7/10. Number 2 is doing B, point B as a fraction. So I'm going to look right here, there's my point B. Now if I look at my benchmark fractions, I can tell that 1/2 goes right in the middle, and then that kind of divides it right in half. And so, and then I can also look at my decimal right here being 25 hundredths. That is the benchmark fraction of 1/4. One is greater, is 70 hundredths or 1/2 greater. Which one is farther right? There's B, which is the 1/4 or 70 hundredths. It is definitely the 70 hundredths or 7/10. For number 3, there are two ways you could do this. It does tell you to locate them on a number line. So you could use the number line up here if you wanted to, or draw your own. Or we can just worry about this one fraction and make it a decimal. Remember, fractions are just another way of writing division. I'm going to work out 2 divided by 5 over here on the right to find out what decimal is 2/5. So this one works out nicely. I don't have to add a lot of zeros, and it looks like it's 4/10. So if I had them on a number line, I would have 4/10, and then I would have 46 hundredths, and then a little ways away I would have 55 hundredths. So which one has the greatest value? That would be the one on the farthest right, the 55 hundredths. For the on your own, make sure that you use a number line to get your bearings. Figure out which one is either the greatest, the least, or the greatest, depending on what it is, and work on the problem solving. When you're finished, press play and you can check your answers. So what I did for this one is I just kind of estimated. I wrote out my benchmark fractions, and then I said, well, 4/10 is just a little bit less than 5/10, but it's more than 25 hundredths. 3/4 is a benchmark, and then 15 hundredths is less than 25 hundredths. So I can still answer the number with the greatest value.